This is actually my first talk, so I'm pretty nervous. Basically, I'm not going to go too much into detail about my introduction. I'm a junior researcher at Nova University of Lisbon, just to south of Lisbon, in Caparica, at the Nova Links Research Center. These are my social media links. If you want to follow me, they are great. And I want to explain why I'm here. Basically, for my master's thesis, I'm writing a database benchmark, and I needed to fork Riak's client, Riak's Erlang client, and add support for modern Erlang versions. So I got in touch with Russell Brown on the left, so we started interacting. And as soon as I found out that the Google Summer of Code applications were open, I basically spammed Russell Brown's Twitter inbox until he agreed to mentor me in a project. Later into the internship, Brian Hunt and Gordon Guthrie were also roped into the project, but this is just to say that my talk here is the result of our combined effort. So basically, I'm just going to provide a background and motivation for the work that we did. We're going to go into Riak Test, which is a tool that Basho developed to test Riak. We're going to go into some of its internals, and then I'm going to explain how I was able to improve Riak by actually burning it to the ground. I'm going to discuss some future work related to this internship, and a final word about Google Summer of Code. So to start the talk, I actually need to take us back in time, back a few years ago, when Basho was still around and they made Riak. And Riak was this database that was being marketed as an emerging database with these three important properties that I consider there are four, but operational simplicity is outside of the scope of this talk. But these three properties, high availability, scalability, and fault tolerance, were sort of the pillars of Riak and still are. My talk is about testing. So if you're selling a database that supposedly has these features, you should at least test if they are actually there. So I'm going to show you how Basho did that with Riak Test, but I actually want us to warm up to it first. So let's think about something more general. How do we test the properties of any system, not just a database system? So any system is bound to have code modules that are simple, more or less self-contained, so they are good candidates to use something like unit tests. So in Erlang, you would typically use a unit to do that. Sometimes things are inherently aligned with using other techniques like property-based testing, but for most purposes, Erlang developers use common tests because most non-trivial test suites require some sort of setup and teardown. And here I have a very, very simple test suite. This just tests a connection to a Riak server. We have init per suite and end per suite callbacks, and they do the setup and teardown of the database respectively. So here I'm just starting a local Riak server, and then I'm shutting it down in the teardown function. And the test case itself, it can be arbitrarily complex. Here I'm just opening and closing a connection to the database that I started before. This is very simple, but it is a good example of the building blocks that you get to build test suites with common tests. So it has some pretty cool features aside from the setup and teardown callbacks. You can test individual code modules, or you can test entire applications. This basically means that common test can look at the system under test as a white box, but also as a black box. And above all, it's also the standard for Erlang development. So this is you see this a lot. You typically don't see, unless it's a library that doesn't have state, you typically see only common tests, only common test suites for testing. But common test seems to be cool and all, but this right here is Riak's dependency graph. So it's just this massive thing with tons of dependencies. I can't even zoom in so that you can see the letters. Otherwise, things just go outside of the window frame. But the idea here is that we have this very complex system that needs to be tested somehow, and each one of the nodes in these graphs are sometimes their own Erlang applications. So each node in that graph is probably going to have unit tests, common test suites, and when you actually use all of these dependencies to compose Riak to build the database itself with all of these different versions associated with them, sometimes it's difficult to just use common tests for this. And this is basically some motivation as to why Basho was driven into developing Riak Test. Some things that aren't that trivial to set up in common tests. One thing is single releases under different OTP versions. This one has an easy cop-out. We typically use something like Travis CI or Circle CI to just test our systems under different environments, which may include different Erlang versions. But if we start to think about testing different release versions or testing the interactions between different releases, it's going to start becoming more and more complex to do that using just common tests. And this is basically what led Basho to develop Riak Test that in a way that was tailored to what it needed at the time. So Riak Test provided the properties that I showed in the slide before. So it's able to, you're able to select a Riak version, an Erlang version, and it's going to download and compile every Erlang version, every Riak version that you can possibly select, compile everything, and then run the tests against the version that you selected. What happened with Riak Test basically is that it didn't age well. It's passed some years since it has active development, and basically it became a barrier of entry for new contributors, and we're going to see why in just a moment. But to simplify, it's just hard to get working, and it's very cumbersome to use. OK, so Riak Test has three main components. We're going to go into each of them in varying detail, but first we're going to look at the test runner script. So the test runner script is basically a wannabe replacement for common tests. So it does sort of what you'd expect a replacement of common tests to do. It runs some tests, collects results, but it uses custom test suites, and it basically gives it terrible error reporting, as we're going to see in a few moments. This is a trivial test suite that is run, that is implemented in Riak Test. So what we have here, we have a module which exposes a single confirm zero callback, which either returns pass or fail. The return of the confirm callback is obviously the logical value of the test success. And OK, you might think, OK, with an example this simple, it isn't that bad. I think I could use this. But this is just the confirm zero callback of the simplest test case that was actually inside the Riak Test repository. So I know this is a bunch of code, but I'm going to go into detail. So what's happening here, I had to condense the code a little bit. What's happening here is that we're spawning a bunch of nodes individually, and then we're making sure that when they're on their own, they are able to perform operations on 100% of their own ring. And then what we're going to do is we're going to load data into one of the nodes, and then progressively add nodes to the cluster and check that the cluster membership is correct and that we can access the data from every node in the cluster. So this is already a bit of a pain to look at. And if you actually run this, OK, it runs because the test has been written, I don't know, 8 years ago or something like that. And this is the output that you get. After about 400 lines of console logging, you get this one test pass. And I didn't put that there. That's actually there, the 100% for those keeping score. OK, so this is what I showed you is the success example. But I actually want to make it fail in order to show you why it's so bad. So what I'm going to do here is in the step where we're joining nodes to the cluster progressively, at the last point, I'm going to I'm going to basically say that there is one less node in the cluster. So I've removed node 4 from this list, and I'm saying that after we join node 4 to the cluster is going to be composed by nodes 1, 2, and 3, which isn't true, so it's going to fail. And this is what we get. It's a bit of a nasty stack trace. And the Riak Test people probably understood that, that this is probably not very pretty to look at, so they pretty printed it. So, well, if you look at this for long enough, you eventually get to a point where you actually understand where the error is coming from. Here we see that it's coming from verify build cluster, which is the name of the test suite, and it's coming from line 55. And then what I like to call the cherry on top is that if the test fails, it actually prompts you to leave Riak running in order to debug it. This is basically this is a big insight into what sort of the target audience was for Riak Test. It was basically just Riak committers, people that knew the code base really well and that could go in and debug the issue live on a running server. So it's not really a good fit for any particular developer that is looking to make a contribution to Riak. And now that Riak is basically a community effort, it would be good if we could improve the situation. I'm going to pause for the Riak test runner for now. This is basically a summary. So we've seen that it doesn't support any test cases. It's just a confirm 0 callback. And we basically have to debug any failures in the tests through the exceptions that are thrown when the tests fail. And then if you think that it looked bad when you run a test and it failed, running multiple tests that fail is even worse. OK, moving on to the code intercept library. The code intercept library, in my opinion, is awesome. It's a library for performing arbitrary computations on a system that is already running. You can use code intercepts in order to do some sort of chaos engineering, like some sort of chaos monkey thing, where there is this server that is running already, and then you modify the code at runtime to add, for example, a delay to the response and see what breaks. Because sometimes internal components of the system make some assumptions on the response times that requests take. And when you sort of make the assumptions go away, things start to break. And this is a very good way to test for the robustness of the code that was written. So this is one of the intercepts. This is actually code that's used to test Riak. Okay, so this one is an intercept for Riak KV vnodes. And basically what we're doing here, like I hinted at before, is that we are handling a request by sleeping for half a second and then actually calling the original request. Sometimes what you also might want to do is drop requests. And in this case, you can configure an ETS table to drop requests for certain partitions of Riak. And then this just shows you that we are, it's basically going to go to the table and seeing if the partition that was requested is in a list of partitions that we want to drop. If it is, we're going to drop the request and not reply. Otherwise, we're just going to call the original one and it will get a normal reply. So now how it works in practice. So we have a test suite that calls this RT-intercept add, and it receives a node module, and then it receives a reference to the model on which you want to put the intercept and the intercept itself. For instance, we saw that for the same module, we can have multiple intercepts, and here you can choose to add just a few of them. So a call is made to RT-intercept, and what happens is that RT-intercept is going to fetch two modules. It's going to fetch the original code module and the intercepts module, and it's going to compile the intercepts module as the original module, so that it's substituted by the old original, And the original one is compiled with the orig suffix over there. So you might be wondering how this happens. This basically happens at runtime by first compiling the file locally, and then just not locally, remotely through the first RPC call, and then the second one we're actually loading the binary and replacing the code that was running before. So now let's look at this same example again. Basically, you can see that we are defining a macro here named m, which is the original module. This is why the m is defined with the orig suffix, is because there is an assumption that the code intercepts library is going to compile the original module with that suffix. So that's how we are passing the original request through to the original module. Okay, and how is this actually used in practice? So there's a total of about 40 test suites that use intercepts, and sometimes more than one intercept is added. And this is key, like I hinted at before, this is key to test the robustness and the assumptions that are being made into React's internal components. Sometimes we add delayed responses, like we saw before. Sleep, you can sleep for half a second, you can sleep for 10 seconds and see what breaks. But sometimes what you do if we want to test some weird anomaly is that you can just fetch a random array of bytes and just reply with that. Instead of replying with the same thing, with the thing that you were expecting, you just reply with corrupt data. Okay, so that wraps it up for the code intercept library, and that now we have the cluster manipulation library. This isn't particularly interesting for the context of this talk. This library is basically used for setting up and tearing down local Riak clusters. It's critical for running the test suites that are inside Riak Test, but outside of it, it's not really that useful for other people. So looking again at Riak Test, we can see that we have we have a script that can live on its own, but then we have two libraries that can obviously be pulled apart. And what we hope to gain from this, especially with the code intercept library, is since it's not tightly coupled to Riak Test, that we can decouple it and actually make it available for others to use, since we think this is a feature that people might want to use outside of Riak itself. So we were able to pull the libraries away from the main repository, and now we have this test runner script, which is living on its own. It has a dependency on the two previous libraries and also on Riak, of course. This is how we would test Riak. So now we had to go from here. So we have this test runner script that has this weird way of working. It's not really developer friendly, and there isn't enough resources to work on it to make it better. And I tried to salvage some of the code, but eventually in the group we all decided unanimously that the best would be to actually burn it to the ground. So no more test runner scripts. So now we needed to find a replacement for it. And of course we left things behind. So the Riak Test had about 300 test suites in total, which is a lot. I had never seen so many test suites all bundled together before. And we have a bunch of, I basically break it down here on different categories, but I think the most important ones are React TS and React Ensemble, because there was a significant number of test suites that related to features that eventually got deprecated or that are no longer supported. So if we wanted to migrate the old custom test suites over to common tests, in fact, we wouldn't have to bring 300 test suites over. In fact, it will be way less. So it was actually doable. So when we were replacing React Test Runner with something else, we actually knew pretty much what we wanted to use. So we wanted to use common test because it's the standard tool. We need to keep code maintainable. So that was definitely something that we wanted to use. And also Rebar 3, because we think that some of the features that we had before can be replaced by some of the features of Rebar 3. And I'll get into more detail about that in a couple of slides. Obviously, we want to retain as much functionality as possible, but sometimes it's just not easy to. It's just not possible to migrate everything over. So our constraints to move over is that the Riak code base is stuck on R16 and rebar 2. And I know this is just a single bullet on a slide, and it kind of looks like it's a small constraint, but I look at it more like this. R16 is going on, is about to turn, I think, 5 or 6 years old. I cannot remember for sure. And it still used rebar 2. Now, the good news is that maybe I'm not the right person to say this, but I know that there is an ongoing effort, and there will be a release very soon, hopefully, of Riak 3.0 that is actually not going to have this problem. But at the time that I did my internship, this was a big problem. So, adding rebar 3. Can it be done on such a large project? Basically, we went back to the list of releases for rebar 3. The interface for rebar 3 doesn't change at all over time, so we basically just pulled the release that was compatible with Erlang 16. We added the binary to the repository, and basically, whenever we wanted to test if things worked, we used the local binary of rebar 3 instead of using the user's version, which, of course, wouldn't be compatible with an older version of Erlang. And the advantage for this is that when Riak 3.0 comes out and it supports modern versions of OTP, the only thing that I need to do is just pull the old binary out and just use the user's version of rebar 3. Okay, how do we test for different versions of Riak? So basically, we accomplish this with rebar 3 profiles. So by default, the new Riak test is configured to add a dependency of Riak which just follows the tag that is on master, or the latest tagged version, for example. But if we have major releases like Riak 2.2.6, for example, and if we wanted to test run the entire suite of tests against this particular version, we can use something like rebar 3 as Riak 2.2.6 CT, and that will run the batch of tests against this particular version. And this basically happens because we override the dependency reference to a tagged version of Riak. So this is how we did that part. And okay, so the only thing missing here is actually migrating the custom test suites over to common tests. And we were not able to finish all of them, but we basically wrote a recipe for migrating all of the test suites. We've seen before that the custom tests, the verify build cluster tests, clumped everything together in the confirm 0 callback. So basically, what we do is just perform cluster setup and teardown in the appropriate places, because Riak Test used to do that transparently. Not in confirm 0, but actually sometimes it would spawn a cluster if you didn't say anything, which was a bit weird. And then the entire code that was inside confirm 0, which at some point could be as long as like 500 to 1,000 lines of code, can be broken apart into individual test cases, which are each going to get a meaningful name. And we'll see what difference this makes. So the verify build cluster test that I showed you before, in fact, on those lines of code that we saw, didn't exactly test one thing. It actually tests 5. So this is just the header, the beginning part of the file, where you can see that there are exactly 5 tests that are being done. So if a developer tries to make a contribution and suddenly tests start blowing up, the developers will be able to tell that it's failing, for example, when the node leaves the cluster and not on line 55 of the test suite. So this basically improves drastically the reportability of the previous solution. So the current status of the new Riak tests. We are able to test the different release versions through the rebar 3 profiles that I mentioned. We are also going to use the same cop-out to test different releases under OTP versions. We just forward it over to Travis CI and Circle CI. But I'm not saying this is impossible, but for now we don't have a mechanism to test the interactions of different releases. This is useful, for example, if you imagine that you have a Riak cluster on version 2.2.3, and you're going to add a new node that is on version 2.2.6, for example. You want to test how they interact together to see that things don't break if you match different or if you use a cluster with different versions. And finally, this can also, of course, using different versions of Riak can also spawn across different OTP versions. This was something that was able to be done before, but now we don't have manpower to work on this. Some bonus objectives that we reached. Basically, now the code intercept library is living on its own repository. Basically, it's the first new repository in the Basho organization in a long, long time. It's really, I think the library is awesome. I think you should check it out. So it's if you go into the GitHub organization page of Basho, I think it should be the first one in terms of activity, and it should be just github.com/basho/rt. Okay, so this is the end result. Now we have a bunch of test suites that I wasn't able to fit in this slide, but we have a bunch of test suites, each with their own meaningful test case name, and everything is working for the suites that have been migrated. Of course, some are still being migrated. So this wraps it up for the story of my internship, but I actually wanted to go into a meta commentary about the Google Summer of Code program. Maybe some of you don't know what it is. Basically, it's an online international program that encourages university students to participate in open source software development. And students have to work with an organization, and if they complete the program, they win a stipend. And the good news is that Erlang and Elixir have a single organization, which is called the Beam community, that aggregates all projects. So Google has a sort of a quota of internships to give to each organization, and there is a single organization, a single umbrella organization for BarrelDB, for LASP, for tons of Elixir projects that I don't really know about, but I know that there are a bunch of them in there. So we have a vehicle to do this in the Erlang community and also in the Elixir community. I would like to end with a note that you should, if you would like to participate in Google Summer of Code, you should. I think for me it was an amazing experience because I got to work with more experienced developers. I can tell you that sometimes I was stuck on something for several days, and I was expecting to go ask my mentors for something, and then okay, I'm stuck on this part. And I was expecting them to just gasp and say, okay, I'm going to have to lose time helping this guy. But oftentimes, they just knew about something that I didn't. They just said, oh, okay, you just need to do this and that, and then it will work. So sort of hidden secrets that are not really there for beginners, but they are really important to bridge the gap between beginners and experienced developers. The second reason why you might want to consider being a mentor is that your work may actually impact the community. For example, Benoit Chenot, which is here today, has a bunch of libraries, and one of them is the most used HTTP client, I think so, which is Hackney. And basically, let's say that you are using Hackney for something and you'd like a feature to be added, but you don't have the time. As a Google Summer of Code mentor, you might be able to, without having the time to actually implement the feature yourself, actually help the student go through that process, help him learn a lot in the process, and get that pull request accepted without much effort from your part. It's just more of a supervisional aspect. And finally, I don't think that it does require a big time investment. In my case, I booked a weekly meeting with my mentors of about 30 minutes to 1 hour, depending on if I was stuck on certain things. But basically, I just reported on the progress and told them if I was stuck on something. So I don't think that this is particularly a big time investment, especially if there are multiple people involved in the same project, because sometimes if one can't make it, the other one can, and it's enough to help a beginner like me. And I think the Google Summer of Code project should have more visibility in the Elixir and Erlang communities, because they are somewhat smaller communities, maybe not so much on the Elixir end, but the people that belong to the communities are really motivated and are really excited about the technologies that they use. So this is the note that I would like to end on, and that's my time. Thanks.